All right, let's go ahead and look at this problem. It says use a graph of h of x shown below to evaluate the limit of h of x as x approaches -3, if possible. So there's a couple of things to think about, and let's look at it in terms of the definition, and let's see if that helps us understand what's going on. The definition says, let f of x be a function defined at all values in an open interval containing a. So the open interval, it's not really strictly defined here, but we're basically considering, say, this open interval from here to here, from say -5 to 1. That's just arbitrary, just to have something to draw from. And then it says it contains a. So yes, that contains -3, because -3 is right there. Okay. And with the possible exception of a itself. So in this case, h of -3 is a little bit problematic because it's not on the curve, but that's not gonna keep us from finding the limit. It says if all the values of the function f of x approach the real number L as the values of x not equal to a approach the number a, then we say that the limit of f of x as x approaches a is L. In other words, as we move in this direction, okay, or along the curve, we're approaching -4. So what's happening is this is getting closer to -4, and this is getting closer to -4 as we move from the left, and as we move from the right towards -3. Therefore, the limit of h of x as x approaches -3 is equal to -4, no matter that the actual value of h of -3 is different. In this case, the actual output is -2, but we're more interested in this open interval and what's happening as values approach from the left and or the right. They don't use that terminology in this case, but you'll see it come up later. And so that's the way you ought to be thinking about this problem.